Hi there. This will be part 2 of the preview of the TCS CS-105 Command Station. After the release of part 1, there was a number of comments and suggestions and critiques to part 1. Thank you everyone for submitting those. I'm going to try and implement them in the upcoming part 2 and, by the looks of it, part 3 and part 4. The way I'm going to structure this now is focus on specific asks or questions or functions of the command station or the system itself, break it down into shorter segments, or make parts one single segment dedicated to that function or ask that was put up on the forums or the mailing lists. Many of you are interested in consisting with this new command station, and I feel that subject is also important and deserves a video of its own. Another question was about integration of JMRI with this new command station and whether you can use it over the wireless, and that's what we're going to explore in this video. I hope that you like this better, and of course if you have any comments and suggestions and critiques in the future, please leave them in the comments or on those forums and mailing lists where I post the links to this video. I'd like to say a few words about pricing and positioning of this command station. Since the video part 1 was released, TCS has posted a number of pages on their wiki, and one of the pages that covers CS-105 actually shows the pricing and MSRP of $529.95 US, and the release date of 9th of August 2022. I don't know whether you were expecting the cost of this station to be $529 or $429 or something, but all things considering, what you're getting here is not just the full DCC command station. It also does all the LCC, and it has Wi-Fi built in. It's a 5 amp booster inside it, or a power output. So there is a lot of bang for the buck packed into it from the get-go, and you get everything in this small package. I mean, when you look at this, it's just that, and there is nothing more. I mean, this is the throttle that's outside it. When you think about the competition, you need to buy either additional external boosters in case of NCE, or their packages, and you need to buy wireless access points. With Digitrax, you still have to buy again the base command station, and you have to buy the LNWI or something else, UR93. You need to buy the throttle. The throttle needs to be duplex or wireless or whatnot, and so on and so forth. So when you add all these things up, well, it does add up to more than this command station. So I would argue, and I'm not being paid to say this, that there is really no reason to buy any other command station than this one. If you don't have one, or if you're planning to replace your existing system, or you're looking to do any future proofing, I mean, this is the command station to go for. That's just my personal opinion. Before we continue with part 2 in earnest, I'd like to do a bit of errata. In part 1, I was showing programming the long address of the locomotive on the programming track, and actually went the long winded way about it. There is a shorter way of doing that, and if you use your WT and you go to CV programming, there is DCC address right here. So you would just put the locomotive on the programming track, and then you can basically enter the address, either this long or short, whichever one you like. You can also clear the consist address. You can set the consist address. These are the CV19, I think. And so you don't really need to fiddle with the, CV17 and whatnot, and 19. If you want to program these things, you would just do it through the shorter menu there. The other thing was about the boosters, and the booster diagram with the command station I've shown showed booster B105 or 106, but then I called it 105, and really it wasn't really sure what it was. Well, I think it's B106 based on the TCS's wiki pages. So the command station is CS105, the booster is B106. The diagram shows connecting a common between the boosters, or booster if you have only one, and the command station. And then I've described my setup where I have lens boosters which do not have a common, and the only thing I have running is the LCC network between them. The TCS wiki suggests to run the common between the boosters if they have it, as a way of preventing voltage doubling when locomotives cross power districts. Now, if your boosters are fully isolated, then technically this should not happen, but they consider it a good practice of using common anyway. And the other way of connecting common, if you don't have a common, I would say, you would connect the ground on your DC input supply from your booster to all of the boosters together. But that means that you have to run a wire throughout your entire layout between the boosters and the command station, and I didn't like that. So either way, they're leaving it to users to decide whether they want to run the common if they're utilizing TCS infrastructure, meaning the command station and the boosters. They suggest to do so because the benefits of that, as I said, are preventive measures of voltage doubling and whatnot. Boosters that have full isolation are, as I said, lens, NC, TCS, meaning fully isolated front to back. Thus, to recap, if your booster is fully isolated, common is optional. If your booster is not fully isolated, then you really need to consider running a common because of the mentioned power doubling that might happen when the boosters are out of phase, or in some locomotives with split frames where pickups are between the tender and the main steam locomotive. Things can happen when they cross power districts. In this segment, we are going to explore connecting the command station to JMRI. There was a question about whether the command station can connect via wireless in a station mode, meaning that the command station will not be an access point, but will act just like a normal client, and assuming that no owner owns a JMRI running on Raspberry Pi, because a lot of people run that Raspberry Pi image with JMRI, you could use Raspberry Pi as a Wi-Fi access point, and you can probably connect about 12 clients, maybe between 9 and 12, and depending which Raspberry Pi you have. So the question was, can you run JMRI on Raspberry Pi through wireless, connect the command station through wireless, and also connect the throttles, both the LCC throttles from TCS and WiThrottle. So I've sort of jigged something around. We are looking at the command station. You can see that LED 1 is on, meaning the track power is on, and LED 3 is blinking. It's trying to connect to an access point. When that LED 3 is off, then the command station is running in access point mode itself. When the LED is on, then it's in a station mode. When it's blinking, it's trying to connect to an access point. And we have our usual 392 Montana rail link. I'll put in the track and ready to run. So on the other end, I'm going to take you to Raspberry Pi, which I don't have connected. So I'm going to pause the video and boot up. Actually, let me just show you what I have here. This is a 7-inch LCD display. You can buy it on Amazon. And you can see it's not plugged in anywhere yet. And then there is a Raspberry Pi here. This is 3B plus. And I have an CAN interface on it, or CAPE. the LCC or the CAN interface is not connected to the LCC network, you can see, so everything is wireless. This is basically all standalone. There is nothing wired to this system here. So I'm going to power it up, and then we'll start JMRI, and then I'll show you what's happening. I had to compile and run a hub on this Raspberry Pi. Compiling hub is not a big deal, I mean, but I might provide the hub pre-compiled for you if you need to run it on your Raspberry Pi. It just depends which version of the operating system you have. It might need different standard libraries or whatnot. So anyways, the hub is running, the LCC or OpenLCB hub is running in the background, so that JMRI can connect to that hub, and then all the information between the Wi-Fi network, the LCC network, if you have a wired network through a USB or something, all of that is going to be, routed in between each other and then going to JMRI. So I'm going to pause this video now, and in a blink we'll have the JMRI up and running. So here is the desktop booted up. I forgot to mention that there is obviously an access point Wi-Fi enabled on this Raspberry Pi, and there is a DHCP server serving any IP addresses to any clients they want to connect. So because this is booted up, I'll take you back to the command station, and now you'll see the LED3 is on. It means that the command station has connected to this Raspberry Pi over wireless. There are no wires here, and there are no wires here. So we'll start the Panel Pro. It's running OpenJDK, which I find it's much slower than running Oracle Java. I'm running 5.12 JMRI, I think. It's still a beta test, or it's a test version, but you can run anything over 5, I guess, or whatnot. Doesn't really matter. I was saying Java, I would run Java 11, but you can see here what the version of JMRI is. I would run Oracle Java because it's faster. I've noticed it's faster than OpenJDK. In any case, we have the LCC. LCC is configured, and I'll show you that. Oops. Preferences. I'll show you the configuration for the LCC connection. So it's using the Grid Connect. And remember, I said I had to compile hub. Well, I had a hub compiled before. So I'm using CAN via Grid Connect network interface. And I've specified localhost and the port. This is the IP address where the hub is running on, localhost meaning Raspberry Pi, and the standard port 12021. We don't need that, we can close that. And then if you go to LCC, and you say configure, no, I don't want to start the hub. LCC, configure nodes, you can see the command station registered as a node. Remember, none of this is wired, it's all wireless. And command station is also a client to Raspberry Pi wireless. It's not running in access point mode, and it's registered on the LCC network. So basically you have a bridge between the wireless and the Raspberry Pi. And so now if we go back here and we turn the UWT on, UWT is also configured to connect to Raspberry Pi station. So let's boot it up. And if I can get the light to turn on this, there we go. And you see it's connected to the LCC network. And there is the 392 moving there, you can hear it. See? And I have running it speed step 5, 3. So let's just stop there. And now to see the actual LCC network, you can see that 392 is registered because every locomotive on the LCC network is a node, and we have the TCS Throttle UWT100 also registered. Again, this is all wireless, and 392 is on the throttle. Next, I'll start the engine driver. And here is the engine driver. Oh, the viewing, no, it's good. You see, there is nothing there yet. It's not seeing that JMRI there because this did not start the WiThrottle server. So we say here, servers, start WiThrottle server. Let me do that right. Servers, start WiThrottle server. Now it's listening. And now if we go back to the engine driver, permissions don't matter. See, I can say my JMRI railroad, and hopefully it will connect. Oh, it can't connect. Timed out. I don't know why it's connecting to a wrong Wi-Fi network. I have several networks here, so excuse me for that. It should be LCC WLAN. And let's see now if it can connect. And looks like it's connected. If I select by DCC address 392, acquire, we have acquired the locomotive. And just to prove that it works, there it goes. And I'll stop it. But here is the cool thing. I don't know if you can see the UWT. They're both showing it's moving. The lighting is pretty bad. So it says 0 right now on both. But if I move the WiThrottle up, you can see and you can hear. Well, I don't want it going away. Let's reverse it. And you can see the locomotive is moving. And here we see 19 speed step. Well, 24 on the UWT, but it doesn't really matter. I mean, there is a disconnect probably in the way they measure speed steps. But just shows that you can use the engine driver through WiThrottle while you're running your UWT in LCC mode, and everything is going through JMRI, and you can see the whole LCC network. So I think that should answer the question, can I run JMRI and make it a central point for all of these things to interconnect? And the answer is yes, you can run it if you have it already, and you can make the command station run in a station mode, and then it will connect to your JMRI, and you can run your WiThrottle server on the JMRI, and then if you have any mobile devices, you can run your Android driver, and all of this will happily work together with the LCC Throttle. And just to make it a point about wireless, I'll take you back to the dark here. If you go to settings, you can select DCC station settings, and it will find the command station. Even though we are not running, we're not directly connected to the command station, we're connected through this Raspberry Pi wireless network. It still finds the command station, and you can do the same settings you were able to do when you would connect the throttle directly to the access point of the station. So it just shows that whether you have the station acting as an access point, or you have Raspberry Pi, or you might have a home router, it doesn't really matter. The networking will all, figure itself out. As long as you have a hub, and the hub is listening on all the interfaces, all of these things will just discover themselves and speak to each other as needed. I hope that this is answering the question about JMRI and wireless connectivity. Before we wrap this video up, I have one more thing to show you. Through kindness of some people, I can't name them so they don't get overwhelmed with requests, I was able to obtain a native LCC handheld throttle for Android. This app is a proof of concept, and it's not really available to the public, but it gives us a glimpse into the future of what's possible with LCC, native LCC on our mobile devices. So if we run the locomotive, you can see it changing just like the WiThrottle, and you can run the bell, horn and whatnot, change direction as well. But beyond that, this app lets you configure the train, just like you would do it in any other LCC node in JMRI. In a moment you'll see that all the settings for this train are available in the app. But that's not all. You can actually configure the command station. It loads the complete configuration into the app, just like UWT100 does. And the significance of that is that you don't need JMRI or the computer to configure the command station. Matter of fact, you don't really need that because there is your throttle. But beyond that, you could configure all of your other nodes that you have on your layout. Whether there are circuits, tower LCC, signal LCC, or something else, they would all be present on the app. The app could have a configure nodes menu window just like JMRI does, and you would just select the node from that window, and that's all you need really, your mobile and the app. You don't need to have a computer to run a JMRI or some other program. You don't really need the UWT100 or 50 for that matter even. I imagine, you could program your locomotives with this without a need for Decoder Pro, especially if they're on Railcom. All the LCC instructions will go through the wireless network, whatever they're supposed to go on the locomotive, or through the command station, as I said, because you can control the command station from this app. So I hope you see that the possibilities are there, and it looks very promising, the future of LCC and this command station that's sort of giving us these abilities, and probably all the other ones that will come after it. That's it for this video. Thank you for watching, and I will follow up with another one soon.